Hello, my dearest viewers. I'm Teacher April, and today we're going to discuss about electromagnetic spectrum. This is one of the topics in Science 10, and it's still related to our topic about electromagnetic waves. So let's have first our review about the electromagnetic waves. We will have it in a form of fact or bluff. I'll be showing you 6 different statements, and you decide whether it's a fact, if it's true, and bluff if it's false. So let's start with statement 1. Electromagnetic waves are considered as longitudinal waves. Is it a fact or a bluff? You may write it first on your paper. Then later on, I'll be showing you the answers. Let's proceed to number 2. Electromagnetic waves are also called EM waves. Number 3. James Prescott Joule developed a scientific theory to explain electromagnetic waves. Next, the electric field and the magnetic field vibrate parallel to each other. Number 5. All EM waves can travel at a speed of 3.0 times 10 raised to 8 meter per second in a vacuum. And the last one, the properties used to describe EM waves are amplitude, frequency, period, wavelength, speed, and energy. Let's find out the answers. Number 1, electromagnetic waves are considered as longitudinal waves. The incorrect phrase there is longitudinal waves. It should be transverse waves. So this one is a bluff. Number 2, electromagnetic waves are also called EM waves. Yes. So instead of saying electromagnetic waves, you can just use the shortcut or the abbreviation EM waves. Number 3, James Prescott Joule developed a scientific theory to explain electromagnetic waves. It's a bluff. Why bluff? Because it's not James Prescott Joule but James Clerk Maxwell. Number 4, the electric field and the magnetic field vibrate parallel to each other. Okay, this is bluff because it should not be parallel but perpendicular to each other. Number 5, it's a fact. All EM waves or electromagnetic waves can travel at a speed of 3.0 times 10 raised to 8 meter per second in a vacuum. And the last one, it's again a fact. The properties used to describe EM waves are amplitude, frequency, period, wavelength, speed, and energy. Let's now jump into our lesson for today. So our learning objective in today's lesson would be to compare the regions in the electromagnetic spectrum in terms of wavelength, frequency, and energy. Now, what you're looking at is the electromagnetic spectrum. So this spectrum consists of the 7 types of EM waves. You have their radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Let us define first electromagnetic spectrum. You can read the definition silently or you can read along with me. Electromagnetic spectrum is a continuum of electromagnetic waves arranged according to frequency and wavelength. Now looking at the electromagnetic spectrum, you have there the 7 EM waves which are arranged according to wavelength and frequency. These red waves here represent the wavelengths of the EM waves. And wavelength, if we define it, it's the distance between 2 points in a crest, which is expressed in meters. Now, observing that the radio waves, microwaves, infrared, these 3 EM waves have longer wavelengths compared to ultraviolet, X-ray, and gamma rays. So looking at the number line, it is indicated here that the wavelength on this side here is longer compared to the wavelength on the opposite side. So we can say that the radio waves have longer wavelength compared to gamma rays. And gamma rays have shorter wavelengths compared to radio waves. Now, how about the frequency? We said last time that the frequency is the number of waves passing in a fixed point. So it is expressed in waves per second or hertz. Now, looking at this number line, it said here, lower frequency. On the opposite side, higher frequency. So gamma ray, having a shorter wavelength, has a higher frequency, while radio wave, having a longer wavelength, has lower frequency. So we can say that wavelength and frequency are inversely proportional to each other. Now, how about the energy of an EM wave? Although the energy of an EM wave is not shown on this electromagnetic spectrum, put in mind that the energy of an EM wave is dependent on the frequency of the wave. So we can say that if an EM wave has a lower frequency, that means lower energy. While an EM wave having a higher frequency means higher energy. Therefore, we can say that the energy and frequency are directly proportional to each other. Now that you know the relationships between wavelength and frequency as well as energy and frequency, we will be having a short activity. You may do this on your notebook. Okay, this activity consists of two parts, A and B. Part A, directions. Compare the following electromagnetic waves in terms of wavelength, frequency, and energy. Write the symbol less or less than if it is less or smaller than, while greater if it is greater or bigger than. Use the EM spectrum as your guide. Number 1, microwave is blank infrared in terms of wavelength. Number 2, radio wave is blank to gamma ray in terms of wavelength. 3, visible light is blank X-ray in terms of frequency. And number 4, infrared is blank UV in terms of frequency. And the last one, radio wave is blank gamma ray in terms of energy. I'll give you 20 seconds and timer starts now. Time's up. Let's reveal the answers. For number 1, microwave is greater than infrared in terms of wavelength. Number 2, radio wave is greater than the gamma ray in terms of wavelength. Number 3, visible light is less than X-ray in terms of frequency. And number 4, infrared is less than the UV rays in terms of frequency. And number 5, radio wave is less than gamma ray in terms of energy. How many answers did you get right? Okay, now let's proceed to part B. Part B, write the EM wave in the box. Use the EM spectrum as your reference. We have only two items here. For number 1, you arrange these EM waves in increasing wavelength, starting from gamma ray, X-ray, then the third EM wave. For number 2, you need to arrange these EM waves in increasing frequency. So what would be the first one, the first EM wave, followed by the visible light, then UV. I'll give you 20 seconds. Timer starts now. Time's up. Let us answer. Number 1, from gamma ray, X-ray, if it's increasing wavelength, the third EM wave will be UV rays. Did you get it right? And number 2, What would be the first before the visible light and the UV rays? If it's in increasing frequency, it will be infrared. Yes. Did you get it right? Okay. So now we will summarize what we have learned about the electromagnetic spectrum. So let's define electromagnetic spectrum again. It is a continuum of electromagnetic waves arranged according to frequency and wavelength. Now, if we talk about relationships, there's an inverse relationship between wavelength and frequency. Frequency and energy, on the other hand, are directly proportional to each other. From the longest to shortest wavelengths, the regions of EM spectrum include radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray. According to decreasing frequency and energy, EM spectrum includes gamma ray, X-ray, ultraviolet, visible light, infrared, microwave, and radio waves. Remember these key points because this will help you answer correctly the next activity. Let us check your understanding. I'll be giving you 5 items multiple choice type of test. So select the letter of the correct answer. You may write your answers on your notebooks. Number 1. A wave with high frequency would have relatively blank. A. High energy and short wavelength. B. Low energy and short wavelength. C. High energy and long wavelength. Is it A, B, or C? Number 2. Which of the following statements is true? A. Ultraviolet have longer wavelengths than microwaves. B. Gamma rays have longer wavelengths than X-rays. Or C. Gamma rays have shorter wavelengths than infrared. Let's proceed to item number 3. In the EM spectrum, the wavelengths get smaller as the frequencies get higher. What is the relationship between wavelength and frequency? Is it A. Directly proportional, B. Inversely proportional, C. Independent of each other? Now let's proceed to items 4 and 5. Use the number for the EM wave below to correct the sequence. Use 1 for X-ray, 2 for infrared, 3 for UV or ultraviolet, 4 for radio wave, and 5 for gamma ray. You can copy this on your notebook so that you will be guided later on. Again, use 1 for X-ray, 2 infrared, 3 UV, 4 radio wave, and 5 gamma ray. Are you ready? Okay, question number 4. Which sequence of numbers is true about increasing energy? Is it A, 2, 3, 4, 5, 1? Letter B, 5, 2, 4, 1, 3? Or C, 4, 2, 3, 1, 5? Number 5, this is the last item. Which sequence of numbers is true about decreasing frequency? A, 1, 3, 4, 2, 5. B, 5, 1, 3, 2, 4. C, 4, 1, 5, 2, 3. Let's reveal the answers. Number 1, the answer is letter A, high energy and short wavelength. So a wave with high frequency would have relatively high energy and short wavelength. Number 2, which of the following statements is true? The answer is letter C. Gamma rays have shorter wavelengths than infrared. Number 3, the wavelengths get smaller as the frequencies get higher. What is the relationship between wavelength and frequency? Your answer should be letter B, inversely proportional. And number 4, which sequence of numbers is true about increasing energy? The answer is letter C, 4, 2, 3, 1, 5. Again, the answer is 4, 2, 3, 1, 5. Letter C. And number 5, which sequence of numbers is true about decreasing frequency? And the answer is letter B, 5, 1, 3, 2, 4. Again, 5, 1, 3, 2, 4. Letter B. So what's your score? Did you get 5 over 5? That's great. So now you're ready to do this as your assignment. Cite some practical applications of EM waves. So you can either go to Google to look for answers or use your Science 10 learner's material or textbook. So again, this is Teacher April. Thank you for watching this video, and I really hope that you have learned something new today.